Hi, in this video we'll be solving literal equations. So what do I mean by literal equations? I mean that we'll be rewriting these equations so that we are isolating a variable that is not yet isolated. This is a very useful skill in science and in other areas, so let's begin. All right, so in this first question, we are being asked to solve for x. So notice that x is over here, it's not by itself, and the goal is to get that x by itself. And we've done that with solving one-step and two-step equations, but typically we're finding a number. Now we're actually finding it in terms of an expression. So I'll show you what I mean. All right, so right now we have m on that side. We want to get m away from that side. So we would subtract it from that side of the equation. And whatever you do to that side, you also have to do to the other side. And so over on the right side, we get negative x equals, and on the left side, we get z minus m. And so we're almost done, but notice that we do still have a negative sign here. And so in order to get rid of that, we can divide or multiply by -1. And that will get rid of that negative. Whatever you do to that side, we have to do to this side as well. All right, so here we have on the left side, negative z plus m, because those signs change, is equal to x. And so we've isolated or x, and that is how you solve a literal equation. But that one was not that challenging. Let's take it up a notch and keep getting a little bit more challenging. All right. So here we're asked to solve for x. Once again, I keep saying m, but we're being asked to solve for x. So that means we are going to try to get this x alone. Right here, we have 2c being added. And so I want to remind you that when you're solving an equation, and we did this before, we are solving backwards. So we're going in the opposite order of PEMDAS. So here we are going to take that 2c away from that side so that we can get x closer to being alone. Whatever you do to one side, you do to the other side. And so you get negative 3x is equal to minus 3 or negative 3 minus 2c. All right, and so now we just need to do the opposite operation here. So right now, negative 3 is being multiplied by x. So I'm going to go ahead and divide both sides by negative 3. And everything here gets divided by negative 3. And we get on the left side, x by itself, which is what we want, is equal to 1 plus, because we have a negative over a negative, 2 over 3c. And so we've isolated or x here. All right, let's keep going. Let's make this a little bit harder. All right, so now we're being asked to isolate a. And we have a both in the numerator and in the denominator. So the first thing I'm going to do is I'm going to multiply both sides by a in order to get that fraction to not be a fraction. And hopefully that helps a little bit. So on the left side, we get ag, and on the right side, these cancel, and we get equals 1 plus 2a. All right, so now we have a on both sides of the equation. And so we have to make a decision. Do we want our a's on the left side or on the right side? And so since we have this 1 over here, I'm just going to move this away from that. And I'm going to be subtracting 2a from that side and moving it over here. So on the left side, we get ag minus 2a is equal to 1, and that cancels on the right. All right, so now we are getting closer, but we still have a lot of things happening here. Let me move this out of the way so we can get some room. All right, so here, if you are in Algebra 1 and you have not yet learned how to factor, This is something that you'll be learning later on. You can skip this part of the video or you can keep watching. So we are going to divide everything by A, but we can't just divide by A because that is going to mess that side up. So we're going to do something called factor out the A. By factor out the A, we are going to take this A, put it here, and now we're going to divide everything by A. So again, if you're in Algebra 1 and you've never heard of factoring, not to worry too much. All we're doing here is we are doing the opposite of the distributive property. So notice that if we were to distribute the A here, we would get what you have up here. So we're doing that backwards. And don't worry, you would not get this in an algebra class until you've learned how to factor. All right, but it is good, still good to preview this. And that's equal to 1. All right, so now we're almost done. So now remember that when you don't see an operation here, that is multiplication. So we can go ahead and divide this by G minus 2 on the left and do the same over here on the right. And we get that A, now it's finally by itself, is equal to 1 over G minus 2. All right, so I did want you to see a hard one so that you know that this can be done even if it looks challenging. All right, so one final question. I want you to see this being applied. So here we have an actual physics equation, and don't let that scare you. This is something that you'll see, and once you know how to manipulate these equations, you'll be able to rearrange them in a similar way. So in this question, you're being asked for a formula or an equation for acceleration, and that's A. So we need to get this A alone. And so the first thing is, again, thinking of PEMDAS, you're going to go in the opposite order of PEMDAS. So you're doing subtraction or addition first. So we're going to go ahead and take UT away from both sides. On the right side, we get a half AT squared is equal to S minus UT. All right, so now this fraction kind of looks annoying. So here we are dividing by 2, or a half is the same as dividing by 2. So I'm going to do the opposite here and multiply that side by 2, multiply that side by 2. And on the right side, we get 2, and then parentheses, S minus UT is equal to AT squared. All right, and so now we're almost done. That T squared, we don't need it to be there. So right now it's being multiplied by A. We're going to strip that away and divide. And whatever you do to the right, we have to do to the left. And so we get that 2 times S minus UT over, all over, T squared is equal to A. And now we've rearranged the formula. Now we have a formula for acceleration. So you've just done physics and you should be very proud of yourself. All right, that's it for now.